virtual chapter session. My name is Carlos Bassi, and I'll be your host today. This is our March meeting. We meet once a month. And so today I think we have another great session for you. Can you move to the next slide, Warner? I want to tell you a little bit about us. I'll be the moderator today, and I'm on the board of the virtual chapter. My name is Carlos Bassi. You can reach us in a lot of different ways and see a lot of our information out there. We're on Twitter. You can see our Twitter handle and our hashtag. You can go to our website and sign up and get on our mailing list. And we also post recordings of the sessions there. We also have a discussion group, and we have an email if you need to reach us. The next slide. Everything for this session is being done through your computer, so you should be able to hear us through your computer and see us through your computer. You won't be able to talk to us through your computer. The only way to ask a question would be to type a question in the question box, and I'll take those questions and then ask Warner later. If I can answer your question, I'll answer it right away just through the box, through the spot in the web meeting that we can ask questions. Warner would like questions to be held till the end. Now, you can ask questions during the session, but what I'll try to do is hold them off and then ask Warner when he finishes. He'll leave a little bit of time for questions at the end. Next slide. One of the things we want to do is thank our sponsor, SolarWinds. They've been a great sponsor of this group and have been sponsoring it for several years. We give a gift card of $100, an Amazon gift card for every session. So one of you who's in our session today will receive this gift card. And so they've been a great sponsor, and just want to make sure you know that they're doing this for us, and want to make sure we mention them. Next slide. Another thing I want to make sure we mention is the past Business Analytics Conference. It's going to be held from April 20th to the 22nd in Santa Clara, California. Right now you can get $150 off if you use the code DABCPE. It's down at the bottom left-hand side of the slide. If you're interested in analytics, visualization, and a lot more, it's a great conference to go to. I went last year, and I really recommend it. So please use the code we show below so you can get another $150 off the registration time. Next slide. And so now I just want to get to the presentation today. Our presenter is Warner Chavez. He's going to be talking about profiling a problem query with XEvents and SQL DMVs. And what I'll do is I'll hand it over to Warren. Warren, you can switch over to your own slide deck now. And please introduce yourself first and then go on with your session. And thank you very much, Warner.
Hey, thanks, Carlos. And thanks everybody for joining today. It's my pleasure to be here on this session of the Performance VC. I'm just going to switch over to my slides now. This session has very little slide content, I promise you. It's going to be mostly maybe like 2 or 3 slides I created, and then we're just going to go through demos, and then we'll have our Q&A in the end. Right in there, my name, Warner Chavez. I'm SQL Server MCM. I work at Pythian. If you guys want to check out my employer, it's pythian.com. And I also blog at my own blog called SQL Turbo. If you guys want to check out the blog as well, the link is right there. And the topic for today, we're profiling queries with XEvents and DMVs. And I'm really going to focus on the new 2014 Profiles DMV. And how we can get events information from it and metrics and how it works in general. Because it's kind of a peculiar DMV, and we'll talk about that. So very short about me. I've been a SQL Server DBA for about 10 years now. I previously worked at Hewlett-Packard as a level 3 DBA. I'm now a principal consultant at Pythian out of Ottawa, Ontario. I'm a SQL Server MCM. If you guys want to shoot me a tweet, there's my Twitter handle right there. If you want to shoot me an email, about anything about the session today, if you think about something later on, just feel free to use that email right there. And if you want to visit the blog as well, where I cover some of this stuff too, and very likely we'll be posting all the presentation material at the blog later on today as well. Okay. So, what's the agenda for today? Well, my goal is to show you guys some of the profiling capabilities that are available with extended events and with the new SysDM Exec Query Profiles DMV. This is a new DMV that was released with SQL Server 2014. It's available both on Standard or Enterprise Edition. It does not matter. And I just really wanted to do a very, very practical session. So it's all going to be about the demos. So the first demo, we're going to do some response time analysis with extended events. So basically, we're going to capture weights information and see what kind of output extended events can give us with that. Then we're going to mix it up with the DMV for demo number 2. So we're going to be profiling a pretty standard query. It's not going to be too complex with DM exec query profiles, and we'll see what the output looks like for that. For number 3, we're going to be profiling a query that's a little bit more complex. With the same thing with DM exec query profiles, and then we'll see what kind of I would say maybe secret information we can get from the DMV that we usually would not get just from the execution plan. And then demo number 4, we're going to jump back into extended events just to show another thing that you can track with extended events that's pretty cool, and that's a specific I/O activity for a specific session using the extended events bucketizer target. And then on the last demo, we're going to bring it all together, and we're going to do we're going to take the query from demo number 3, and we're going to profile it with DM exec query profiles, and we're going to run weight stats analysis on it, and we're going to be running the profile for I/O activity, and I'll show you guys what that looks like in the end. Okay. Some quick assumptions. This is not an intro to extended events. I mean, I'm going to assume some familiarity. I will go through a little bit over the different parts of a session definition, just so that everybody can follow regardless if they're experienced with it or not. But it's definitely not a full-blown intro to XEvents. Same thing is not an intro to DMV concepts. I'll assume some familiarity with it, especially in comparison of how this new query profiles DMV works compared to more classic DMVs. And then concepts like tasks or threads, I'm assuming that the audience is familiar with them as well. Same with like basic concepts of execution plans, but regardless of that, I'll try to make it just as universal as possible for everybody. All right. And that is it for my actual slides material, at least before we jump in straight to the demo. So let's just do that. Let's just jump straight to the demos. So I have a prepared VM here on my laptop. So I'm going to show you guys. I got the Windows Server 2012 running. Okay, and just really quick, I want to show you how it's set up. So I got 4 cores, and I got 3.5 gigs of RAM. And currently on my laptop, we're sitting on it's a mixed hybrid SSD magnetic drive as well. So it's good for demo setting, and it'll be good enough to show the concepts for today. So let's just jump right in. So I'm going to go straight into demo number 1. So like I mentioned before, demo number 1 we're going to do is response time analysis. So what I'm going to do now is I'm going to be creating a session, an extended event session called RTA Analysis. And this session is going to capture 2 different events related to weights. And they are SQLOS.WeightInfo and SQLOS.WeightInfo external. Now the difference between those 2 is that WeightInfo will capture all the weights inside SQL Server, and if there happens to be any weights outside, so more like Windows related, then they would get captured on this the info external event. In this case, I'm going to be using the event file target. So that is basically just a file on the file system that will receive in all the events, and then we'll capture it from there. If you guys can see as well, I've set up a filter there where we're only going to capture the events for session ID 63, which is my current session right now that I'm going to be running on. Okay, and then all we're going to do is, once I have this session up and running, is to run this what I call our tunable query, which is an store procedure called salary analysis inside a mucked up database that I use for most of my demos called HR. Okay, so let's just do that now. So I'm just going to create the event session. I'm going to verify that it was created as well. I usually just quick check on the GUI, so it's you guys can see it's right there. It's the RTA Analysis, and I'm just going to start it up. I'll start it up, and then we'll be ready to capture information from it. So let me start that up now. And it's running now, and now I can just simply run the tunable query, like I said. And then we'll run that. And that query is done. It did affected a bunch of records. It took 8 seconds more or less, but that should be enough just for showing the response time analysis capabilities. So we can stop it now. And the way it works, if you're not familiar with extended events, I did not specify in the definition, I did not specify a path. So by default, it'll go into the log folder of the instance. So I already have it, or I had it here. Let me jump into it. Here we go. And then if you guys can see here, the file is right here. Okay, so those are .xel files. And the cool thing about Management Studio in general for the 2012 and 2014 is that even though extended events existed on previous versions, you couldn't really process the files easily. But nowadays, you can just drag and drop, and Management Studio actually opens the file. So if you guys can see there, I just basically dragged and dropped it, and then Management Studio gives me the file information. You guys can see there we have all the events, we have the weight info, and they are time-stamped. And then I'll show you guys also for each weight event what we get at the bottom. So we get a duration, a weight type, so I can, for example, specify here, I can see that the weight type here was SOS scheduler yield. So basically our thread was doing work, and then every so often, I think it's about every 4 milliseconds or so, threads are required to yield the CPU just in case for the other tasks that SQL Server needs to run, right? So it basically means we were on the CPU, then expectedly SQL Server took us off the CPU, and then we got a CPU again probably, and so on and so forth. Now the cool thing here as well is I can add columns to the display. So if I want to see, for example, the duration, as well as the weight type, I can add them, and then they'll just come up here. So I'm just going to zoom in on that as well. You guys can see now the display, I have both duration and weight type. And now the other cool thing I can do, once I have them like that on the GUI, I can actually group and aggregate. So for example, I can group all the events by weight type. I'll do that and say OK. And then if we check out, we'll see that during my salary analysis store procedure, there's two different weight types registered, right? We had, oh, sorry, let me do that again. There we go. So we have SOS scheduler yield with 3,298 events of weight, and then write log with 800 events of weights. So the interesting thing here as well too is that we can see that we keep track of the amount of events, but we also kept track of the duration of those events, right? So on the surface level, if we checked out SOS scheduler yield, well, we will see we have more weight events than the write log, but we also have aggregation here. So I can aggregate the duration and just make it a sum and say OK. And then we can see, for example, then even though there were easily, let's see, 8 to 32, that's 4 times. So even though there were 4 times more weights for yield in the scheduler, actually the duration time of the weights is very, very close. I'm going to zoom in on that just in case you guys can't see it well over there. So if you guys can see right now, there's 3,200, almost 3,300 SOS weights on basically SQL OS scheduler weights, and only 800 for the write log, but the wait time for both of them is actually very, very similar, right? The two numbers here for the sum of the duration is actually very similar. And that kind of makes sense. I'm going to show you guys, to finish up this demo, just show you guys what that particular store procedure is doing. So let me open it up. Okay, and then you guys can see it's a very simple store procedure. It just takes an integer value, and then it iterates over that value, and then it updates the salaries by a certain amount of numbers. So as you guys can see, well, now the weight types kind of make sense. Yeah, what these pages are all in memory, so there's not going to be any I/O to read the pages, but every time we're updating these salaries, we're doing I/O to the transaction logs, hence the write log weights. And this is all in a loop, a very tight loop there with no weights or anything. So clearly, without any other thing to impede the progress, every now and then SQL Server has to just take the thread off of the scheduler and then give it back almost immediately. And that's where the scheduler yield weights come into. Pretty much every process will always have some scheduler yield weights because SQL Server is cooperative on how the threads get scheduled, right? So now we can see how those weight types are related in this case to what the store procedure was doing. And I want you guys to keep that in mind because we're just going to take this weight types type of analysis and we're going to apply it at the very end for the last demo that brings it all together. So and then there's a lot of possibilities inside extended events. In this case, obviously, just for the purpose of the demo to give you guys some ideas, I'm going to be focusing on the weights and the I/O. But there's tons of more stuff, and I'll go through that a little bit on the recap as well, give you guys some ideas. So that's it. So that will be demo number 1. Remember, just very simple. Even through the GUI, you guys can do this analysis. You get the weight types, you get the sum of it, and you get them on a per session base, which is something that you can't do with the classic DMV. For example, if I go, you guys can see this, I can just do a select star from sys.tm OS weight stats. Now if I go here and I select from this, all the weights are general, right? These weights are server-wide. They are not tied to a particular session. Whereas the extended events way, it's tied to a particular session. Now there's also another DMV that's related to weights, and that's DMOS waiting tasks is right here. And then this DMV is on the session level. But then the problem there is that this DMV is updated constantly in real time. So if you wanted to catch every single wait event that goes through a specific session through this DMV, you would have to have basically a loop constantly reading this DMV to get the different wait types for your session. Completely non-practical, and you're probably going to make the server do a lot more work than it should. So that's why the extended events way is the way to go for this. So that's demo number 1. Recap, remember, just per session weights. Best way to capture it is with the extended events. And the cool thing about it is that it allows you to as well do some aggregations to really see not only the amount of weights, but the actual duration for those weights as well. Okay? So with that out of the way, let's move over then to our next demo. And this demo is going to focus exclusively on the sysdm exec query profiles new DMV in 2014, and I'm going to show you guys what we're going to do. So I have this query here on the same HR database. Now if I run this query, you guys will see it takes about 5 or 6 seconds to run, and then it should be done. I'm just going to let it finish. So there it is. So it took 14 seconds actually this time. I guess my cache is cold right now, and it generates a parallel execution plan. If you guys will be able to see, let me zoom it into it. So we're doing a table scan and then hash match, computing some scalar values, and then the parallel zone ends. Okay, so it's not a completely super complicated query, but it runs for at least enough time to let us see what it's doing. Now, I'm going to jump into another window and really quick show you guys what the DMV looks like. So let me do it here. I'll just show you guys. So this is just a normal select star. So as you guys can see, it's empty. So that's the first peculiarity of this DMV. It's not always collecting information. So for the DMV to start showing information, you need to be basically requesting the exec plan from the engine. So for example, if I go back here and I say, on Management Studio, just include actual execution plan, then while I'm running it, it'll actually populate the DMV. Or if I were to use some of the other, like for example, guys know we can do something like set statistics profile on, and that'll give us the text execution plan as part of the output, then that as well will force the DMV to get populated. So basically any instruction that makes produces the execution plan at the end, then that populates the DMV. So I'll show you guys, for example, if I run this again, so it's running right now, and if I try to run this again, you guys will see the DMV is now starting to get populated. Right, so now it has information on it. If I just click this again, suddenly it's empty, right? So basically what happens is the DMV will have information while the query is running, and after that it's gone, right? So if you want to, like, for example, if you have a query that takes 20 minutes or something like that, then sure, you have a lot of time to just go in and, at minute 10, you start seeing the real-time updates of the DMV, and you still have 10 more minutes to look at it. But if I'm saying, let's see, for example, just this query that's 14 seconds, it doesn't give us a chance really to analyze anything. I would have to, try to analyze everything in 14 seconds before the query is done, and then it disappears. So what I did is I created a table that will have the contents of the DMV. So what we're going to do is we're going to be inserting into the table the contents of the DMV, and I added some control values there so that basically I can run this window and then start the other query on the other window, and then this loop here will be capturing the stats from the DMV every second. Okay, so if you guys see here, I added a wait for delay of 1 second. So that means we'll capture the deltas of the DMV information as 1 second values. So let's say the query takes 10 seconds to run, then we're going to do hopefully 10 captures. If the query, let's say, were to run only 2 seconds, then we could do 1 capture, hopefully 2. You could tweak this to be even below that if you really wanted to see every single update of the DMV, or not every single one, but maybe, let's say you could run this to 500 milliseconds and then have double the output, right, and double the captures. I find, probably 1 second is good enough for most setups. And then at the end, we can analyze it, right? So let's just do that. So I can run this. So that's executing right now, and while nothing is running on my SQL Server, then this is not going to be capturing any information. Now I'm just going to rerun this query. So we have it here, month, year, employee. So just going to execute that again, and we'll just wait for that to finish. So that's finished, and if I switch to this side, it's also done. So this one completed as well. If you guys can see here, it wasn't capturing anything at the beginning because I started this first, and then it doesn't capture anything, anything. And then at some point, it starts to capture every single iteration. It starts to capture from the DMV. Capture. Let's keep scrolling down here. And then at some point, it doesn't capture anything, and the query, the script stops. Right. So at this point, we have all the information we wanted to on the DMV, and I can go in and see what we got from it. So I'll show you guys, for example, very quick. So stuff that we can get out of it, I added this capture time so that I can order it so I know what information belongs to what loop. So if you guys can see, we have information here that goes from the time on the VM right now is 11:32, so the VM is right now on Pacific time. So that's 11:32:24, and if I scroll all the way to the end, we'll see we go all the way to oh, sorry, I forgot to actually delete the previous run that I did earlier today as a test. So our captures actually start here. It is on EST time. So 14:25, and I go down all the way to 14:25, but on second 55. So we go from 14:25 second 41 to 14:25 second 55. So if you guys can see, as long as the timestamp is the same here, so all these are on second 41, it means this is the entire output of the DMV on that second. And then this one, all on second 42, this is the output of the DMV on that second run, or that second run of the loop. And the way it works, it actually gives you a row per operator of the execution plan. So in this case, you guys can see, for example, let's focus on the easier ones, which would be the table scan, the two table scan operators. So you guys can see, for example, cool things that you can see right here off the bat. We have two different threads, so thread 1 and thread 2. If we go back to our execution plan, we will see that indeed it is parallelized. So and you guys can see right here where I see the number of executions. It is set to 2, right? So those are thread 1 and thread 2 right there. If you guys can see as well, when we did the capture at second number 1, so the first second of the capture, then the row count, or how many rows each of these table scans had read, was 218,000, and the other one had read 230,000. And the estimated amount of rows in the end is supposed to be 10 million, right? So, and as we go through the different captures of the DMV, we can see, for example, on the second, then we had almost 1 million that each thread had read, then 1.7, then 2.5, then 3.2 and 3.3, 4 point something, all the way to the very end. We can see once, the last iteration, it was almost the 10 million here on thread number 2, and then more than 10 million on thread number 1. Okay, so with the DMV, we're able to see the progress of the operators, how they're doing their work. And not only that, but we can also see how much time they have spent. Okay, so we can see, for example, let's see something very interesting. For example, if we go see and check the execution plan, well, we can see we have the table scans, we have the hatch operator, and then the cost of them, 57% versus 43%. But then we can go and see here as well. We can see exactly the amount of time also spent. So for example, we have the CPU time here, and we also have the elapsed time. So something really interesting, we can see an operator, for example, like the stream aggregate. Let's go and see it here. Where is the stream aggregate? This operator right here, right? Even though it has an elapsed time of 13 seconds, because it was waiting 13 seconds for all the other ones, it only has one CPU time, right? So very interesting. Like for example, we know then that this operator activates at the beginning. It's same thing. It just waited 13 seconds for this entire thing to go through, right? And then on the other side, we can see, for example, the table scans, how long they took as well. So the table scans here, each one took about 3.3 seconds of CPU time, and actual time that they were waiting was 3.3 as well. So very similar CPU time and elapsed time means these table scans did not have a lot of weight. They were usually on the CPU, right? And then the hatch match was as well very similar. The elapsed time and the CPU time is very, very similar. So it means they did not go through many waits as well, right? And then the cool thing, like I said as well, you can see the parallelism. You can see thread 1 and thread 2. And we can also even see the object. So I can see that these tables was on this HR imported data table, right? Okay. So that's pretty much how it works. Just to show you guys again, let's go back to the output of the DMV here. So basically we just captured on every loop, and that way we can do the analysis after the fact and go through the different stages of the query. If we didn't capture it based on loop, then again, we could have maybe just like captured at the beginning and at the end, but then we miss seeing the progress as it goes through the execution plan. Or if we only catch it at the end, then same thing. Well, basically we miss the history of the whole execution. So if you want to see the entire history of the execution, you can use the script, and I'm going to be posting those scripts as well. So you can use that script to capture it on a tight loop here. Well, it's not even that tight. It's a 1 second loop here. And then you can analyze after the fact and see exactly, what operators were doing work at a particular point in time. Okay. Okay, and before I move on to the other demo, just show you guys some other things you can do with the output of the DMV. In this case, let me scroll down. In this case, for example, you can even get the text and the execution plan as well. So like here, for example, it's this plan, and yeah, well, if I select here as well, I'm going to get the same plan. But on my next demo, we'll see a more interesting case for this DMV, where I get a little bit, like I said, kind of like hidden information from the DMV. Okay, so let's. I'm going to truncate the table that we use for this capture so that we have it clean for the next demo. So we're going to move to demo number 3, and demo number 3 is a very simple query, but it has a common pain point that a lot of people have probably encountered with SQL Server. And if you guys can see right now, I'm just going to zoom in. I have a scalar valued function, and scalar valued functions are a lot of the times an issue because SQL Server doesn't really inline and optimize them with the rest of the query. Instead, what it does is that it calls it as like a separate entity for every single time that you call it in your master query. So in this case, I just have a function called average hours, and it takes a result that's a float, and then it takes a let's see, the average total hours from a table called imported data, and then it just returns that. Okay. And then what we're going to do is we're just going to run a query where we have the right here. We're just doing a select from employees, inner join with the salary, and at the very end there of the column list, we have that average hours function, right? So let me run this right now. And again, to make sure that it outputs to the DMV, I have to include the actual execution plan, or like I said before, you could use something like set statistics profile on or set statistics XML on if you wanted to do it that way. Okay? So we can run this. I'm just going to wait for it to finish. And then in about 10 seconds, we get the employee ID, the hire date, the salary, and the average hours tracked. Okay, and then you guys can see the execution plan. I'm going to zoom in on it. So in this execution plan, we have a clustered index scan, then a clustered index seek. There is no parallelism in this plan. And nested loops on it, and it looks like the highest cost there is that clustered index scan. Okay, so now let's do the same thing we did before. I'm going to rerun it, but this time I'm going to kick off my capture loop here. I'm going to verify that I don't have anything on the DMV so that I don't get confused like last time. There we go. So it is empty, and I'm just going to fire off the capture, and I'm going to fire off the query. And we'll just wait for it to finish. And we have the 10th there, and as soon as this one ends, the capture query ends as well. If you guys can see, we have 12 rows captured per loop of the capture from the DMV, and then at this point, we can just go in and see what we captured from the DMV, right? And I want to just show you guys the exec plan again. So we have in mind the execution plan of this query, and it's a clustered index scan, clustered index seek, nested loops, no parallelism, right? This is a serial plan. Okay, and now let's go into the analysis of the capture from query profiles. Okay, so first thing that you guys are going to notice is that take a look here at the thread IDs, right? So I'm going to zoom in on it. So even though the exec plan that we get off the bat from SQL Server is shows as a serial plan, with the SysDM exec query profiles, we can see that actually there are 3 different threads that are doing work during this execution plan, right? So it is not actually a serial single CPU plan. It is using multiple threads. So it's using thread 0, 1, and 2. And as well, you guys can see that even though the execution plan it's the other one. The execution plan here mentions the employees table and the salary table, right? Those are the only 2 tables mentioned on this execution plan, employees and salary. If we go back to the DMV output, we see that there is the third object there, right? The imported data table, right? So that on the surface, when you would be running the other query, you wouldn't be able to see it. Now in this case, obviously it's a demo example, so it would be pretty obvious for somebody to just go in and quickly see there's only one way that something else would have been inserted here, and it has to be through this scalar function, and go and see it. But think about if you were working with a really massive query, one that does like views inside views, and might have a couple of functions related to it as well. Well, then at that point, you might be thinking, oh, well, I don't even know how many tables this thing touches while it's running, And if I go to the exec plan, like I said, in this case, it doesn't even show all the tables that are hidden behind a scalar value function, right? So in this case, we actually get to see all the objects that get touched by the execution of this query. So we can see here the table scan that happens on imported data, even though it doesn't show up on the execution plan of the query itself. And we can see as well its consumption in amount of rows, and we can see as well its consumption on CPU time as well. Okay. I can go in as well and do the same thing that I did before for this one and get the text and the query plan. And then if I run that, then right off the bat, you guys can see it actually calls out the operators that are part of the function itself. So you can see, for example, row number 4, that's a table scan. Immediately it tells you, oh, that's inside the function. That's what you're doing inside the function. That is not part of the execution plan of the top query. Because even if I go here and I go say, oh, well, show me the execution plan of that select that I did, it still shows you the same execution plan that Management Studio will show up by default, right? The one that looks like one thread, it doesn't touch that imported data table. But the cool thing as well is it identifies the operators that were part of the underlying function. Like I said, for example, the table scan here in create function. And if I click on that one, it actually gives us the execution plan of the function itself. So if you guys can see now, we have the 2 execution plans that are really part of this one SQL call, right? So that's now how it makes sense that there are 3 threads. If you guys can see here, these is a table scan to import the data, and it is a parallel operator. And it goes into a parallel zone, and then it does an aggregate, and finally goes into and gives us the answer every time we call this particular scalar value function. Okay, so we can see then that this one query call, it wasn't, even though if, for example, on first attempt on Management Studio, or if you were running the statistics profile command, it only gives you the execution plan of the top level query. Doing it this way, not only do we get to see the threads, not only do we get to see all the objects that were part of the plan, but also we have access to the secondary, I would say, execution plan that comes into play. And now we can make sense out of the whole thing, right? So that's why we have multiple threads, is because the secondary execution plan, the one for the function, is the one that actually has parallelism. Okay? Yeah, I'm just going to close this down. And then the other information, like all the other stuff, is captured here as well. So we can see, for example, the elapsed time in milliseconds and CPU time for the table scans that are part of the function. We can see them here. You guys can see every time they run, it's about half a second, right? You guys can see if I pick them up again, for example, right here again, they repeat, because they're going to repeat every time for that we call for every row. So in this time, this was 400 milliseconds, 400 milliseconds, and same thing as I go. And here's the other table scan. Something as well, just have to mention it really quick. If you guys see, for example, our first run here is on second number 9. So rows 1 to 12 belong to one capture of the DMV. And check it out. There's 3 threads, right? There's 3 threads for scanning the imported data table, and one of them has a 0 row count estimate and actually will have 0 CPU as well. So it's basically there's 2 threads that are actually doing the work, and then there's one that's like the coordinator thread, and that one is basically just there to coordinate between the other 2, and it doesn't actually do work. And then we can see it here, like I said. We can see which one is which, right? So thread 0 is the one that's coordinating, thread 1 and thread 2 is the one that's actually doing the work. If you if you want to correlate what you're looking at on the graphical plan with what you're looking at on the screen right here, it's very useful. You can see this node ID. So you guys, for example, if there were more than one table scan and you want to see which one is the one that you're dealing with when you see the numbers, you guys can see the node ID here, for example, 6. And let me just go right into the execution plan again. And then you can see, for example, if I mouse over this guy, you guys can see their node ID here. It's equals 6. Okay, so that's how you could go in and find it while you're playing around with this. All right. Okay, so that was demo number 3 to show you guys again a little bit more complex example, and also to show you guys here the really cool thing about how you get more visibility over what's happening than just off the top of your head running a show plan. Definitely for very complex queries, and especially the ones like this one that have function calls, really easy way to see exactly what's going on. And once you have it materialized here in like this analysis table, you can aggregate it, you can do averages over it, you can save the execution plans as well for either selling it to your devs or for your own tuning work as well. Okay. All right. So I'm going to move over now to demo number 4, and this demo is very simple. I'm going to be using the same query that I used for demo number 3. Then what we're going to do on demo number 4 is basically we're going to be using the file read completed extended event, and this extended event, what it does is that it captures information from the file reads that are done by a specific process. So I'm going to be running this, and this is SPID 64. So I'm going to put here the 64 as my filter, because otherwise I would capture, or anybody setting this up would capture every single I/O done by SQL Server, and that's not what I want to do. So with this extended event session, we're going to capture every read done by this particular session, 64, and then we're using the bucketizer here, the histogram target, for extended events. So basically take all the different IOs and it'll put them in different buckets depending on their size. And using this extended event, then we can see the size and amount of IOs that are done by a particular SQL workload. So imagine if you guys have to, for example, size a storage system for your employer, you can use something like this to get an idea of what are the usual sizes that SQL Server is using on our particular workload. All right. In this case, I'm going to dig in just for one. Since we're profiling that specific query, I'm just going to put in the specific session ID here. Also, I'm going to be dropping the buffer cache, so for sure we're going to be doing at least some I/O. So I'm going to run that now. And I'm going to create the session. So the session is running now. Then I'm going to jump back here and run our query. Going to let that run. All right, so that completed. So I can go back here. And, oh, wait, I forgot to start the session. So let me see here. Yeah, I forgot to start it. Sorry about that. So let's start it. That'll be an important thing to capture it. Oh, sorry. IO size is buckets. Okay, now it started. Now I can run this again. Run that again. Yeah, wait for it to finish. All right, it's done. So now we should have information here. Let me just edit here because it's IO size is buckets. And what we do here is basically an X query. Since the histogram doesn't have a file as a target, so I can't just drag and drop it into Management Studio. So I have to actually read it from the XEvents DMVs. So in this case, we have XE session targets. That's where I can get the XML that has all that data. And then I can join with XE sessions and XE event sessions to get the actual metadata from my session that I just created. Okay, so let me run this. Oh, let's see. Author session. Yes, we are capturing. Oh, it's because I forgot to, yeah, it's running. So I clear the cache before the first false start, and then I run it, and then I didn't clear the cache on the second one. So let's try this again. So I clear the cache. Session is running. I run the query. Let it run till the end. Go back, and hopefully there's stuff here. Already an object. Sorry. IO results 2. Let's run that. Alright, now we got data. Got 14 rows. And I can select from it. Alright, and there we go. Okay, so you guys can see with this XEvent session what we get. We get IO sizes and the amount that we did. So for that particular query is all about big IOs, right? 512 IOs, 836 times they were done. After that, 64K IOs, and after that the rest, I mean, there's a bunch of different ones, only done maybe once or twice. But clearly, if I was profiling a workload, then this is what I want, right? We would optimize for big 512 kilobyte IOs, okay? And that's pretty much the demo of the capturing I/O for extended events. Now I'm just we have about 8 minutes to go, so I'm going to jump into the last demo, which is going to be putting all the things we've seen today together. I'm going to stop this session. Okay, that's stopped. So we're going to put all the things we've seen together, and I'm just going to close some of these down. I don't need this one anymore. All right. So here's what's going to happen. I have this demo here, and it has a extended event session that combines both the waits, so we have our waits, and with the file read completed event. So I'm going to be running that. Then what we're going to do is we're going to run that query to capture the sysquery profiles. Then I'm going to be running the actual long query, and then we're going to go through all the different output that I gathered based on that. Okay, so let's jump right in. Let's refresh and make sure that no session is running. All right, so only system health is running. So let's create this event session. Let's create it. I'm going to clear the cache. I'm going to start it. All right, I'm going to jump right here. I'm going to truncate this so we have a clean table to do our capture. I can start this other capture of the DMV, and finally I can run our long query. Oh, wait, there's the session ID here needs to get refreshed. So let me start that up again. Let me stop that. Let me drop it. I'm going to drop it from the log here as well. Okay, so this is actually 64. 64, 64, 64. Okay, and here I'm going to clear this again. All right, so let me recreate this. That's okay. We'll drop the buffer cache, and we'll start the session. All right, session's running. Then start the capture from the DMV. That is running. And finally, gonna rerun that heavy query. There we go. All right, and that is done. So this one is finished. If we go and check, there we captured the data from it. And then finally, I can stop this one. Should have captured the events as well by now. So we can see, for example, the I/O information that we captured on it. So I have here all the I/O sizes, the I/O mode. If you guys can take a look, we have 65 KIOs, 512 KIOs, scatter gather mode. So basically, the SQL Server does the I/O, leaves it asynchronous, and then comes back and picks it up. So that's the information that we can get from the I/O. We can also get the weights information. So I can run this as well. And then what this is doing as well is just loading from the extended events file, and then it's just counting all the different weights and extracting the information from the XML. So you can see we got some latch EX weights, we got the scheduler yield, we got page IO latch, so basically reading from the disk. We got some CX packets, so related to parallelism. Remember, the function call was parallel. So we got that information as well, right? Now we can actually put those together, and for example, we can see if I run this, this will mash up the IO information with the query profiles information. And then, okay, so you guys can see here, for example, I get this task, the stream aggregate, and the table scan. And right after it, I get all the IOs that were associated with those two tasks. Unfortunately, there's no way to pick to associate IO with an actual operator, like one-to-one. So it has to be from a task. So if two operators were part of the same task, at least we can see that those are matched up to these IOs here. And then, for example, all these here, you guys can see, for example, right here, these operators have the same task, and they match up to these IOs for this task. Then these operators for this task match up for these IOs for this task. All right? And then finally, I'm just going to put it all together with the weights. So this will be the last part of the demos. I'm just going to let that run. I'll show you just quick comment on what it's doing. It's doing the parsing here of the I/O information. So that's this is a CTE, that's called I/O table. Then it's putting that together with the actual information from the query profiles DMV that we captured, and that one is a CTE called a profiles table. And then finally, it's capturing also the weights information and materializing it as a weights table. So now this is what the final product looks like. Hopefully you guys can see it. And then, for example, for each task now, for example, these two at the top, I have this task. They belong to the same task. There's two physical operators. I can also see the IO info for that task. And then I can also see the weight info specific to that task as well. And then as I go back down here, the report is the same thing. I can see, you know, these operators. I can see, for example, these operators right here, these two. If you guys can see, the actual weight information is not associated with, for example, any IOs. So these, for example, these two operators didn't do any IO. The weights that they went through were just having to give up the CPU and then latching, and then CX packets show up but with 0 duration. So you guys can see, as you go through the execution, you can also see specific operators and the weights they went through by joining the two together with a report like this, right? So it doesn't get as like any more detailed. It's just really what you can imagine to put together. So let me just do the recap, and because we're pretty much on time right now. So if, like I said, if there's something you're interested in, it's likely that there's an extended event for it, and you can do a mashup like I did, and this script I'm going to be adding it to the download package, so you can maybe use it as a foundation and then tweak it for your own thing. The query profiles DMV is a bit peculiar on how it works, so you guys can get familiar with it, and you can use a script. Again, you can freely customize the one that I'm going to add, the one that I use there, to capture every single run of it, because that's pretty much what you have to do to be able to analyze after the fact. And also, this is just some demos of stuff that I've been working on, but there's many ways that you could combine it that I have at the top of my head, just haven't had time to do it, because you could do this same kind of mashup with extended events for memory grants, with network I/O. You could be using extended event to capture the CPU level, so when one operator is kicking in, you could see if it touches or it spikes the CPU level up or down. So very powerful stuff, and way more mashups that you could do with the data that I just didn't have, not enough time to cover here, or I haven't just created them myself yet. So anyway, hopefully it gave you guys a really good idea of the capabilities regardless. And that's it. I don't know if there's some outstanding questions.
Yeah, I hope you can hear me fine, Warren. Can you hear me okay?
Yeah.
Yeah, so we did have a few questions, so since we're out of time, I'll try to get through them quickly. Early on, there was a question about the duration values and were they in milliseconds. It seems like they were when you were showing duration.
For the wait event, yeah, for the wait event, it's actually it depends on what you look at. Like for example, sysdm exec query stats will report it as milliseconds. The actual wait event will report it as milliseconds. If you look at something like sysdm exec requests, will report it as microseconds. So just make sure that whatever number you're looking at, if it's not overly clear, just check out books online. But in this case, yeah, the wait event does it in milliseconds.
Okay. And there was also a table you created, or a table called imported data table. And
oh yeah, that's
was that created?
Yeah,
was that created by the SQL engine? Or,
no. That's in the HR schema. That was pre-created by me to be able to demonstrate on the demo that even though the execution plan doesn't mention anything about it, it is being touched there and worked on in the background. So that's all part of the HR database schema, and I'll add a backup of the HR database as part of the download package. So if you have SQL 2014, you'll be able to just restore it directly and run the scripts directly.
Okay. Next question is, for the query profile DMV to return results, we need to enable actual execution plan.
Yes.
So what if I want to view the information of a query generated by an application? So we need to enable either profile or extended events or statistic profile or query post-execution plan?
Yeah, in that case, you would need to enable, for example, the extended event that's like the query post-query show plan, which is a pretty expensive extended event, so it's not recommended that you just enable it for extended periods of time. It's more or less measured to have like a 30% hit on performance when you enable that extended event. So I would just you would do it like for like a minute maybe, and then you would turn it off. The other alternative, of course, is just to set up a normal extended event session or a profiler trace, capture the SQL, and then once you have the SQL captured, you can just copy and paste it into Management Studio and take your time with it.
Okay. Okay, and somebody's saying they're new to SQL Server and they're working with version 2012. Is there anything similar to the DMV demo, even with limited information?
So it's not exactly the same, really. Unfortunately, 2012 does not have a view where you can see it based on operators as it goes through in time. That is definitely 2014 only. What I've done and the type of mashups that I've done with 2012 is, for example, tracking status with sysdm exec requests and the wait types and the I/O. So on sysdm exec requests, you'll be able to see if the query was blocked, for example, or you'll be able to see if what part, like if it's a store procedure, you'll be able to track on what statement it's working on. So it's not as granular, unfortunately, but you can do something similar. You can have like a loop going through sysdm exec requests, capturing the information you want for the session you want, but you won't get it at the operator level. That's that's the new thing, cool thing about 2014.
Okay. So I want to remind everybody that we will post the recording of the meeting and the PowerPoint on our website. But is there anywhere they can get the scripts that you demoed?
Yeah, so let me just jump right into my my first slide, and you guys can see it there. So at the very bottom, that's my blog. You guys see it, SQLturbo.com. So by the end of today, just give me a couple of hours. By the end of today, I'll upload a package over to the blog. You guys can just go into the blog and look for this. There's already a blog post about this presentation. I'll just update that one blog post, and it'll have the download package that'll come with the backup. That's 2014 only, so if you do want to play with the backup, you have to have a SQL 2014 somewhere, or developer, doesn't matter, or a trial. And it'll come with all the scripts as well. Okay?
Okay, great. So there's two more questions, I think, and
Yeah, no worries.
just keep coming in. So, thanks for telling us again where the script will be focused, because people are really interested in that. And by the way, a lot of people would comment about what a great session this was, so we appreciate it. Another question is it required to use DBCC free cache for extended events?
Oh, no. That was only because I needed to clear the cache to generate I/O to be able to show you guys something, right? Because if, for example, I didn't clear the cache and then all the pages are already in memory, when I wanted to show you guys how you can track I/O, well, I wouldn't generate any I/O, right? So that was only for the purpose of the demo. Yeah, if you wanted to run it, let's say if you wanted to profile your production workload, if you wanted to profile it straight from cold, you would drop the cache too. I mean, I wouldn't do that on a production system, obviously. You would replay like a trace on a test system and do that. If you really wanted to just profile a production one, you could run something like that. Don't drop the buffer cache. Normal production systems already generate I/O in a natural way, right? In this case, it's because this is the only thing I have running on my laptop. So if I don't drop the cache, it's not going to generate I/O. But yeah, that's only for demo purposes.
Just for demo purposes. And the last question is there a way to correlate extended events results with Windows performance monitor metrics? And go
yes.
ahead.
Oh, if you finish the question, if it's two-part.
Well,
yeah.
in parentheses, the person asking the question said Profiler was able to do this, if I'm not mistaken. So they're asking.
Yes. Yeah, Profiler, you could open, I think it's a .trc file, and just basically show you the .trc and kind of like match them up in time. I've done it before. What I did was I picked the performance counter output as a CSV, and then after the capture was done, I took the CSV and I imported it to SQL Server as just basically like a table. And then once it's imported as a table, because you guys know importing a comma separated value file into a table is very trivial. You can use even the import data task, or you can use SSIS, just pick the columns, import it, and that's it. Once you have it loaded on a table, you can do like any correlation, right? Because you can just pick, oh, okay, so all the events, like you guys saw that, for example, that capture time that I had, yeah, that would be easy to correlate with the CSV that you generate from perfmon. So it would require a little bit of manual work, but it's not too bad. Like I said, I've done it, and the only trick there, I guess, is that I captured it with a CSV, so it was easy to import. The other thing you can do is there's actually a DMV inside SQL Server that's called CSDMOS performance counters or something like that, and from that one you could capture perfmon info directly from SQL. So you could have like a loop capturing all the different perfmon info straight into a table, and then you wouldn't even need to go through a CSV file. So there's a little bit of manual legwork there, but definitely you can do it as long as you have it on a table in SQL and you have the timestamps to match them up.
Okay, Warner. Well, that's actually the last question. So I want to thank you very much again for doing the session. I really appreciate it. What I'm going to do now is I'll stop the recording, and I haven't ended, so now we're not being recorded. But yeah, I just wanted to thank you personally again, Warner, for doing this, and for I think it was a great session. Actually, a lot of detail and great demos. So.